if you look at tangent, remember it's actually sine x over cosine x, right? Now, in math, you run into issues every time your denominator is 0. Okay? So if you have, y equals 5 over x, if x is 1, that's cool, 5 over 1. If x is 5, that's cool, 5 over 5. If x is 0, 5 over 0 is undefined. Can't divide by 0, right? So, well, here you have sine x over cosine x. Well, every time cosine of x is 0, the tangent is undefined. So tangent is undefined at all points where cosine of x is 0. At these points, the graph of tangent has vertical asymptotes. Okay, so let's think about on the unit circle where cosine of x is 0. Where is cosine of x 0 here? At what? At 0 here is cosine 0? No, cosine is 1. What about at pi over 2? Yep, cosine of x is 0 at pi over 2. Where else? On the bottom at 3 pi over 2. Now, how about if I go up one more time at 5 pi over 2? Yep. 7 pi over 2, 9 pi over 2, 11 pi over 2. So at all of the pi over 2s, right? So this happens at pi over 2, 3 pi over 2, 5 pi over 2, and so on. And also the negatives, right? Negative pi over 2, negative 3 pi over 2, and so on. Okay, so if we take a look at the tangent graph, this is what it looks like. And you see at pi over 2, there is a vertical asymptote. Then there is one at 3 pi over 2 and negative pi over 2. Hey, let me stop here for a minute. Do you guys know what a vertical asymptote is? Yes. Yes? No? Everybody? Okay, so it's basically a line that the graph cannot touch, right? It's an imaginary line that the graph is never allowed to cross. So a vertical asymptote is an imaginary line that the graph can't cross. Okay, now, so if you take a look here, there is one at pi over 2, at negative pi over 2, at 3 pi over 2, right? All the numbers that we just came up with. So remember how we could draw one cycle of the sine function? One cycle of the tangent function looks like this, okay? And it includes 2 asymptotes on either end. So it starts from negative pi over 2 and goes to pi over 2. So now when you ask yourself, how long is the distance from negative pi over 2 to pi over 2? How long is that distance?
1.
1 what? It's 1. Okay, so this much is half a pi, and this much is half a pi. So together, that's 1 pi. So the period of the tangent function is 1 pi. Remember for sine and cosine, we said the period was 2 pi? Here, it's 1 pi. Okay? That's what you need to remember. So everything is going to be in terms of pi. And also, for sine and cosine, it went from 0 to 2 pi. This one's not like that. It goes from negative pi over 2 to pi over 2. So more things for us to remember. Okay, so let's summarize that here. The period of the tangent function is pi. And that initial cycle starts at negative pi over 2 and ends at pi over 2. So let's compare. Sine of x and cosine of x both start at 0 and they go to 2 pi. But tangent starts at negative pi over 2 and goes to pi over 2. Okay? So, to graph a tangent function, remember that term here that we always put between 0 and 2 pi? We're going to do the same exact thing, except now we're going to go from negative pi over 2 to pi over 2. Okay? All right. And then, so to graph, first we're going to do that inequality. Then we're going to graph the asymptotes. And then, go from there. Okay, so why don't we graph one here? So here's the x-axis. All right? Now, this is tangent of x. Nothing has changed, right? What's the period here? Oh, one thing I forgot to mention is to find period, it's pi, and then to find it, you have to do pi over b, not 2 pi over b from now on. Okay, so here the period is pi. All right? Okay. So for these, we're always going to go from negative pi over 2 to pi over 2. So I put my first point, and then I go 1, 2, 3, 4, second point. And it's going to go from negative pi over 2 to pi over 2. Okay. That first and last point are always vertical asymptotes. Oops, not there. Here. Okay. Now. So now, what's the halfway point here? Between negative pi over 2 and pi over 2, halfway point is always 0. Okay, that's the easiest case scenario. So if it's negative a number and positive the same number, the midpoint is always 0. All right, and then what about this green one? Halfway between negative pi over 2 and 0, if you can't think of it, you can always do these, is negative pi over 4. And then this halfway between 0 and pi over 2 is pi over 4. Okay? Now, for tangent, here's how things look. Unless there is a vertical shift, which I'll talk about later, this at the center, right, the point is always on the axis. So look here, I have it here. Plot the center point on the x-axis, always. Now, the points to the left and right of the center, you're going to plot those according to the value of a. All right, in this case, what's a? What's this number a here? 1. That means to the right, okay, so do you see how here the tangent goes up to the right and down to the left? So you always plot the center point at 0, and then if a is 1, at this point on the right, you go up 1, which means you have to go down 1 over there. So here I go up 1, which means I need to go down 1 here. Now, next I graph according to the asymptote. So my graph has to stay within those vertical lines, like that. Okay, so do you see how this x-axis, like the points over there, are still the same? You still get 5 points, find the midpoint, find the midpoint. But then you have, it's kind of even simpler because you just do the the vertical asymptotes, and then you move on. Okay. Let's do this one. So again, okay, so now you have 3 tangent x. This time a is equal to 3. And it's just tangent x, so the horizontal axis, it doesn't change. So you go here. It's tangent, so it's going to go from negative pi over 2, 1, 2, 3, 4, to pi over 2. What's the halfway point? 0. And then negative pi over 4, pi over 4. I do my asymptotes here, graph them. Okay, by the way, if you leave out those vertical asymptotes when you're drawing a tangent graph, I can't, maybe the most you'll get is half credit, but not more than that. Okay? All right, now the center point is always 0. Yeah. No, that's gonna change right now. So it's gonna change right now. When instead of just x, it's another number like 3x, half x, then that will change. And I'll show you how to do it. Okay, here, this time a equals 3. So you have to go up 1, 2, 3. And then you have to go down 1, 2, 3. Okay, and this will be a little bit more like less steep or more steep, right? Okay, refrain from doing this. I often see tangent graphs that look like that. It's not a waterfall, right? It's this, but a little like squished. Okay? All right. Here's another one. This time we have a negative 2. Again, it's just tangent x, so my x-axis is going to be the same. So go ahead and plot those. And I'm going to do my asymptotes here. Center point, always 0. Okay, now a is negative 2. Negative means we go in the opposite direction. So to the right, this point, instead of going up 2, now I'm going to go down 2. Which means here, I go up 2. Okay, so negative 2 means you go down 2 on the right. Okay? How is that looking so far? Okay. Now, to make it a little bit more exciting, now I have tangent of 3x, right? So when I do my x-axis here, okay, because there is a 3 here, okay, I have to do that inequality. So remember for sine and cosine, it was from 0 to 2 pi. Here, it's going to be from negative pi over 2 to pi over 2. And inside, I put this just like before. Okay, so do you see the similarities with sine and cosine? The only difference is these two are different. So now I'm going to divide by 3. If you divide by 3, that's the same as multiplying by what? 1/3. And multiply by 1/3. So I get negative pi over 6 x pi over 6. So here I have negative pi over 6, 1, 2, 3, 4, pi over 6. You can spread it out, yeah. Those are my asymptotes. Now look, here it's asking me what my asymptotes are, right? If you're asked what are your asymptotes, Then all you have to do once you do this is say x equals negative pi over 6, x equals positive pi over 6. Okay. Now, what shape are asymptotes? But they're lines, right? That's what I meant. So asymptotes are lines, right? Lines have equations. It means if you want to state what the asymptotes are, it has to be x equals. It has to be an equation. If you don't say x equals, it's -1. All right, so here must have x equals. Okay, what's the middle point?
0.
Okay, what about this point here? Negative pi over 12. And this one is positive pi over 12. It's the best when it's symmetric like that. Okay, at the center, where do I put my point? On the axis, right? And then at the first point, where do I go? Up or down? Up, how many? 1. 1 because this is a 1. And so that means I have to go down 1 here. See, once you do the sine and cosine, this isn't that bad, is it? It's actually kind of fun. Okay. Ooh, look at those. Okay. Tangent of 1/3 x. Why don't you guys do that one on your own? I'll give you 3 minutes. You have to bound it first. Between negative pi over 2 and pi over 2. Three. Did you guys find the asymptotes yet?
Yeah.
Where are they? Right. So you could either say x equals negative 3 pi over 2, x equals positive 3 pi over 2, or you could say x equals plus or minus 3 pi over 2 like this. Just to save some lead and some elbow grease. Yeah. Okay. All right. So I have way too many points here. This should go here. So then it's up 1 and down 1. Okay? All right, let's do this more exciting one here. Yep. Sorry. Yeah, I was off 1. Okay. All right, here we go. This one, I'm going to go from negative pi over 2 to pi over 2. This time I'm going to put in here x plus pi over 2. Just like with the signs. Now, I'm going to subtract pi over 2 from all 3. right? This one has a phase shift. So so it's not going to be symmetric anymore, right? Which is okay because we can deal with that. So here I have negative pi over 2 minus pi over 2. How do I do that? Negative 2 pi over 2. So it's negative pi x to 0. So so when I put this thing here on the x-axis, I go from negative pi, 1, 2, 3, 4, 0. My asymptotes are at negative pi and at 0. So I say x equals negative pi, x equals 0. Okay, what's the halfway point from 0 to negative pi? Negative pi over 2, right? So it's always it's halfway from negative pi to 0, negative pi over 2. Okay, this one here is halfway from 0 to negative pi over 2. So it's pi over 4. Halfway between the half is a quarter. Okay, this blue one, let's do the math. It's halfway from negative pi to negative pi over 2, right? So negative half plus negative pi over 2. So half of, it's negative 2 pi over 2, right? If I do common denominator, minus pi over 2. So half of negative 3 pi over 2, negative 3 pi over 4. Okay, now, the centermost point, this one, you always put the point on the x-axis. So right there. Now, what's A? A is negative 1. So to the right, I'm going to go down 1 and then up 1. Okay. Okay, and now let's move on to cotangent. I'm only going to do cotangent and then we'll stop. So cotangent, right, is cosine over sine. So cotangent is undefined every time sine of x equals 0. Okay. And again, at these points, there are vertical asymptotes again. Okay, where is sine of x 0?
On 0.
At 0, pi, 2 pi, 3 pi, right? Okay, so before it was all the halves for tangent. Now it's all the whole pi's. So look at this. This is the graph of cotangent. Okay, at first glance it may look the same, but if you look, they're not really the same at all. So look at where the asymptotes are. There's one at pi, 2 pi, and so on. There is also one at 0, and it bugs the heck out of me that the book never puts it, but there is always one at 0 as well. So where does the period, where does it start and where does it end? It goes from 0 to pi. So yet another difference now. Okay? So the period of the cotangent is again pi. The cycle starts at 0 and ends at pi. So remember how here in the beginning we did compare? So sine and cosine go from 0 to 2 pi. Tangent, negative pi over 2 to pi over 2. And then cotangent 0 to pi. So that's pretty much what you have to like keep straight. Okay? All right. So graphing is the same. Okay, what else is different? What else do you notice? If you just take this part, what do you notice as far as the direction of it? It's the opposite, right? Tangent was going up on the right. This goes up on the left. Just to throw another, like a wrench in the situation. Okay, so let's graph this one. Cotangent of x plus pi over 2. So we go from 0 to pi, and we put in here x plus pi over 2. All right? Now, subtract pi over 2. And so I have negative pi over 2, x. Now, if you have 1 pi, and you take away half a pi, how much do you have left? Half a pi. So, I'm going to go from negative pi over 2, 1, 2, 3, 4, to pi over 2. Asymptote, asymptote. Okay, at the center, it's 0. To the right, pi over 4. To the left, negative pi over 4. Okay, always on the x-axis at the center. Now, this time, I'm going to go up 1 on the left and down 1 on the right. So up 1 on the left, down 1 on the right. And that's cotangent. Okay? Okay, now, I'm going to stop at cotangent. The homework for next time is only part 1 because that is just tangent and cotangent, and it's 8 problems. It must be done on graph paper, and you know what? I have some Trig graph paper that I could put on my jag, and you have to draw the axes with rulers again.